who is an empathetic robot. Empathetic robot. And he's going to talk about active inference and collective intelligence. So, while we get the slides ready, give them the lights.
Yeah, I feel really, this audience is awesome. And the speakers, a lot of people shares the same kind of background. This is probably my first time to talk about what we're heading to since 4 years ago, after we create this company. With an audience and speakers like you, I'm so excited actually. I think your question was like, is there any people who strongly disagree with your presentation? I think I'm the guy who strongly support your ideas, and so I'm so happy. But before that, who am I? And I think most of people are probably not living in Japan for a long time. But if you are living in Japan for more than 10 years, I think because 8% of the Japanese population, they're using our service called rinna. So probably you know, but that was almost 10 years ago, 9 years ago. So we start the whole journey. This is a conversation bot, by the way. It's we actually start the journey from 2015, and then I think from 2016, the team at that time we're still a team in Microsoft. The team started to work on deep learning based kind of conversation engine, and we released that in 2016. So since then, we start to talk about generative AI, those GPT, the previous LSTM, RN, these kind of thing. So that's a long journey for 9 years. That's what the company is doing and what I'm doing. I'm currently the CEO of the company, although I'm saying bye-bye to the company. So I'll just give you a very quick kind of demo what this company is doing, apart from language, apart from conversation, so that you understand the company a little bit. Oh, sorry, no. Can I? Oh, no way. So there's no way to. You probably can just open. It's. Oh, no, thank you.
Is it going to talk?
Yeah, just start.
信じる心が大事だよね。大人になってもその気持ちを持ち続けたい。そうですね。でも実は大人になるとサンタさんの役割を果たすこともあるんだよね。それがまた一つの魔法のようなものだね。そうそう。子供たちの夢を守るためのそうか。自分は子供の頃は。
So this is basically a TTS, text to speech. I think this kind of level thing you can hear a lot of other engines are doing, but the thing a little bit different is that, by the way, both of the girls are generated. There's no, so there's a slightly different thing in the conversation is that there has ICC, which is the professor was talking about too. So when one people are talking, another AI is also like laughing or or ha 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 or something like that on the same time, which is not in the text. So it's all predicted and generated. Okay, anyways, this is what the company is doing. Now it's come to the time to talk about the thing. Even out of the company, I'm going to continuously to do this, which is called, so basically we're using active inference to do collective intelligence, which is a perfect match to this audience, I guess. So before that, we probably have to understand some, like we have our definition, sort of definition on the terms. Imagine you are in the morning. You are seeing it's cloudy and getting darker and darker. So you know that you are going to get. I mean, you based on your previous experience, which we call this beliefs, right? Based on your beliefs that you are doing this causal inference, saying, oh, this might be the heavy rain is coming, and then you are saying, okay, based on your belief again, you are saying it could be wet today, so let's get something protect, which is the last line, which is you get your umbrella instead of raincoat, which is your preference. So there's a very important concept about the beliefs, the inference, and the preference. The preference means which one I prefer. Okay, so based on these three kind of ideas, let's talk about currently in the mainstream to heading to the AGI, what people are doing. At the very beginning, everybody knows that DeepMind was doing this, reinforcement learning, and basically they are trying to optimize the accumulated reward using some different ways. One of the ways is searching, but anyways. And on the other hand, OpenAI is trying to do, people are still fighting on is that correct or no, but the mainstream is saying it's a compression. They call compression as intelligence, right? It's compress all the knowledge together and then project those variables into different hyper kind of mixture spaces, so that to make the encoding efficiency higher. But anyways, so there's two different ways to go to heading to AGI. However, there's missing things. I sort of a little bit slightly disagreed with the previous, like the GPT has causal inference kind of thing. Yeah, it has, but from my understanding, it's more like the system one or the fast brain. That's why GPT always get some problems when it's generating bad things or Basically, the point is that we think GPT still also have to some degree causal inference because it's doing this next token, but it's very weak. On the same time, the reinforcement learning is also has some causal thing behind, because you got the state here now, at the time t, and later at time t+1, you update your state. So your next state is based on your current state. That's a little bit causal inference related. On the same, and then talking about belief, actually reinforcement learning has a strong belief. It believes reward. Other than reward, they don't believe. I mean, different implementation of reinforcement learning, they might have different, slightly different beliefs, but most of basically the whole reinforcement learning framework believes reward. While are we the nature intelligence believe reward or no? It's hard. It's hard to say. However, we believe we think it's probably more than reward, right? Something you do is probably not for reward. It's probably for uncertainty, like to decrease, to reduce the uncertainty. It's not probably directly related to reward. But anyways, this is, while talking about GPT, is there any belief? It's very hard to say. It's probably the belief of the people who train the model. Like, I believe I needed some source code to do the inference, the causal inference. Then I put some source code into. That's my belief. That's not the belief of the model. And then for preference, again, reinforcement learning, they have their preference. They are basically using reward to find their preference, train their preference, and later they have the preference. And for large language model, people can input their preference into that, but it's very weak. It's basically prompt and alignment, as everybody knows today. So what this active inference do? The active inference is based on free energy principle. Probably you heard about this, but I actually asked the GPT what is active inference is. But basically, in addition to perceive and observe the world, is also do active things like the very normal, very popular example is that you feel hungry, so you want to grab some food in some fridge. While currently you are in a dark room, then the first thing you do, if normal reinforcement learning, because some other reinforcement learning can actually do this, is that the normal reinforcement learning is trying to try the best, try a lot of times, and to get the reward. The reward is the food. Okay. While active inference is trying to turn on the light first, and then see where's the food or where is the fridge. So that active inference compared to other things is like he is trying to reduce uncertainty first, and then later to get reward later. So for some of the reinforcement learning implementation, they actually also have this uncertainty part, but most of them don't. Okay, so that's the huge difference. And for active inference, the reward part is written in the math. The reward part is basically they call free energy, right? So they are saying all the creatures, all the things are trying to maintain their exist by reducing their free energy. But basically, this is the reward model for the active inference. Then, because of that, active inference can have very strong belief at the very beginning because it's all based in same, so that you can just put your belief in there and put your preference there. And the belief can be updated because you get more training data, or because you are exploring new things, then the belief can be updated. Because you observe the world, the belief can be updated. And then, of course, because this all based in same, this is causal inference. However, one more interesting thing, if you connect to, remember my title is not active inference, but also collective intelligence. So one more thing, interesting thing for active inference is that it also has this property, this so-called self-organization thing. It can self-organize stuff. What does that mean? Self-organization, I think you actually mentioned that, but it didn't explain. So the self-organization is like order or structure of a messy thing can emerge by itself. That's what I define this. To try to explain other people. So this is a way. Then it becomes the self-organization becomes a way that you observe the the microscope and the macroscope. What's the bridge between them? Like how this collective behavior happens is probably because one of the possibility is the self-organization. It will emerge self-organization, and then it can. However, the point I want to make here is that active inference can actually simulate this kind of thing. If you want to have a self-organization thing, if you want to simulate that, you can actually simulate top-down. But most of the emerge is actually bottom-up. Now we're talking about we want to top-down emerge. Then active inference is one of the way you can do this. Just give you one example, which is this graph. It's coming from a paper about active inference and self-organization. Basically, if you imagine these big dots are just the cells, and then together they becomes an organ. So this organ has some function for sure, but the organ also have some structure, like skin and this one is basically the brain, the states to learn the beliefs, and then this layer is action layer, and the outer layer, this one is the sensor layer. Okay, at the very beginning, in this simulation, at the very beginning, nobody knows which one is play which role. However, later, by using this active inference, they actually can emerge. Oh, I know I should be this role, and I should be this sensor role, or I should be this action role. Anyways, these roles are decided by itself. And then, more interestingly, if you zoom into this dot, there's a lot of other dots, which is under the cell. You probably have molecules. Okay, those molecules later can figure out itself what the role they're going to play. The only requirement to generate this kind of, to emerge this kind of structure is that there's all these small dots or these bigger dots knows as a belief that there has three roles, the state roles, or the sensor roles, or the action roles. Okay, this is the only belief or only thing required to generate all the structures later. So this is like what active inference can do. So that nowadays people are talking about agent a lot, and one agent can do something, right? It can do coding or it can do something. And the agent together as multi-agent, they can do more complex things. And what if mass of agents together, it will fit. It can, if we link those, if we do this correctly, the mass, a lot of agents work together can fit the environment. So, and this is what we're trying to do. And do you think, is this true? Like all this math, right? All these simulations, is this true? This is what we did, I think, last year. So we get this MAG, is named, it's basically Microsoft Academic Graph. It gathered 220 years papers, as much as possible, and to link those papers by co-authors. So okay, this becomes a social network of researchers since since 220 years ago. And we gather all the data, and then we try to calculate entropy of this social network. And we're seeing this entropy, by the way, this is not strictly definition of the entropy, but basically this entropy is going down since 220 years ago. That basically means human society also is probably has something order and have some structure, although we cannot see because there has a lot of people, you know. From 200 years ago to now, numbers of researchers grows 100,000 times. Okay, the number of researchers grow a lot, meaning the social network grows a lot. However, the entropy is going down, sort of. While that means there are some orders or structures within that. Okay, is that the only example? Of course, no. There's IMDb, probably NLP people probably familiar with this. Is International Movie Database. That was 120 years data together. We have this co-player social network, and we see the same trend that human nature intelligence, not a single human, but together there's also some structure. There's also some orders in our societies. Okay, so based on that, we although we haven't figured out how to do this, but based on that, we think if there's a mass of agents working together, this agent together becomes then creator or animal. This strange animal is probably going to fit the environment. There must have some order or structures behind the scene, and active inference might be able to resolve this and to at least to simulate what's going to happen. That's basically ends my talk, which is quick. Sure.
Okay, so going to the last part, you're talking about the entropy of these co-authorships.
Right.
So assuming this entropy measure, like this calculation is kind of complex.
Yeah, it's not that complex. So, sorry, is this?
Well, I just wanted to have like an intuitive notion of like what it means for it to be more structured.
Right. This is so the entropy of this social network is calculated because entropy defined by like how many freedoms you have, right? How many degrees freedoms, and how many freedoms in the social network basically means how many degrees you probably have, right? Okay, then we basically calculate the distribution of this the distribution of degrees, like how many people have this number of degrees, how many people have different kind of degrees, and then we can get the entropy. However, if you do this directly, because the social network grows quickly and grows very big, then the number of degrees also grows big. Then you will end up with entropy going up quickly, which is fair. Well, then we actually divide by this random entropy, which means if there's no structure, random social network, given the same number of nodes or same number of researchers, then you can see that it's actually going down, which means there has some structures behind the scene. Does that answer your question? Thank you. Sure.
So does your research here connect at all to something like Ramsey theory, where just by the sheer, which tries to get a handle on something where the sheer size of your structures forces you to have substructures and subpatterns within there? It's not some deep property of substructures themselves, just sheer numbers of things, you're forced to have patterns inside of it. Does your research connect and relate back to any of this?
Yeah, this is not really related to my research, but based on free energy principle, you have to have some hierarchical structures. When I'm saying you have to have, it doesn't mean we created. The nature will ask you to have, otherwise you just die. So based on free energy principle is basically talking about from quantum level, then you get it upper. You get more quantum together, you get more small things together, then you get a bigger until to the human society level. Then you have to have that to make sure that this thing can exist. So it's not directly related to our research, but this is basically what free energy principle is talking. So they are talking in free energy principle. There's two ways to explain. There's one way is to from Bayesian network. I mean Bayesian inference. Another one is you have to have these hierarchical things, and those hierarchical things have to I mean, you have to, those layers have to emerge from button or, I mean, from the world, from the environment around you. I'm not sure if I answer your question.
Yeah, I mean, it's slightly different, but that's very interesting. I mean, so are you saying free energy principle is a deductive theorem where you can say that some hierarchical organizational structure comes out of that? I mean, what, I don't even know what that would, how that would be posed precisely, but is that what you're saying?
I mean, if you're, the free energy principle is talking about the nature thing, right? It's not talking about simulation or
right.
Machine learning or AI thing. So the free energy principle is talking about the nature is composed by small things for sure, and there's hierarchical things. While if we do simulation in our computer, then it becomes like we have to separate those. We have to get rid of some upper layer and some lower layer because we cannot simulate the whole nature. So we have to have a slide from that, and then basically we have Markov things to cut, and then we simulate this only. But even in this even in narrow kind of layer, you the better still have to have hierarchical thing because the bandwidth between communication, right? You cannot have like an infinite, very big bandwidth. Then that means what? That means you have to communicate locally. You cannot communicate with all the human beings at once. There's no way. You have to locally locally. It doesn't mean geolocally. It means you have to. There's a limited number of people you communicate. Then it becomes hierarchical thing. Just like a university, there's a university. There's department. There's different layers of even in human organization. You have to, because the communication channel.
Thank you. I'd love to dig within this more, but it'll take a lot more time. So.
Thank you.
Very much.
Of course.
Yeah. So. Oh. Yeah, I'm trying to understand what the learning algorithm is for free energy principle. Are you proposing this collective thing is the learning algorithm? And does that not assume that the collective things are already intelligent because
no,
these
we
are
cannot guarantee.
But what is the learning algorithm for FEP?
So the active inference is one way to learn, based on free energy principle. It's basically all Bayesian inference. It's not all, but basically it's Bayesian thing. Because it's Bayesian, so it has prior and it has posterior. Then you can continuously update your belief.
Has that been proven in practice?
Huh? Sorry.
Has that been proven in practice to scale?
Yeah, the last part of your sentence is important. I want to ask the same. So.
Yeah, has that Bayesian inference proven in practice to scale for learning?
2 weeks ago, there's a company saying their active inference based model is comparable with DeepMind's Atali numbers. So Atali is the game, and DeepMind was doing that for a long time, right? Like using reinforcement learning, and this company is saying they already computable or even better than that using this kind of
Open
method.
source?
Yeah.
Are you going to talk about verses?
Yeah.
Yeah, we ran out of time. Next, thank you.
We'll Kai to the stage. Kai and I will actually